So if we use our amino acids, do you happen to remember how many amino acids we have? 20. We've got 20 amino acids. And note that of the amino acids that can be used for energy, some of them come in at the point where the acetyl coenzyme A can attach and start them through the citric acid cycle, the Krebs cycle. Some of them come in at a different point of the Krebs cycle, but the same goal is reached. And what goal is that? As they're going through the Krebs cycle, what's happening to them? They're losing electrons. Those little H pluses are following. We're going to shuffle it to that electron transport chain. So these are the ways that you'll see your body using these amino acids, the proteins. And you know, it's really kind of interesting, because when you hear people talk about a proper diet, you know, they talk about, oh, well, make sure you get your proper amount of proteins, get your proper amount of fats, proper amount of carbs, you know, that sort of thing. And they tell us, well, you know, the sugar will give you that quick burst of energy, but proteins are going to give you the sustained energy. And then you're thinking, well, I'm going to shift the body using proteins, blah, 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 okay? But what it's letting it do, it's letting the body work to build up the proteins that are needed. Whereas the sugar, we're not building up anything else in the cell. We're just simply utilizing it and getting the ATP. So it's really kind of interesting what happens. But this is showing you the structure when we deaminate one of those amino acids, how we get the one with the nitrogen compound, and that's the ammonia, okay? And then, of course, our keto acid, which hopefully liver and kidneys can help take care of, but if it becomes a chronic condition, it gets a little more difficult. As we move those amino acids through the process in the cell to get energy, basically the body had to form an amino acid. That amino acid in the cell has to get broken down. As it gets broken down, we get our byproducts, and as that occurs, we're going to strip off the electrons and the H pluses to shift them to the electron transport chain to make the energy. Now, as we look at the molecules that we take in as foodstuffs, as we think about the sugars, the lipids, the proteins, in our bodies, we don't normally think about our bodies being able to make a glucose, to make a lipid, okay? But yes, it does, okay? Now, the reason for that, the one thing that the body wants to make sure is getting the proper amount of sugar, glucose, is the brain. Now think about this for a second. Once again, I'm going to ask my question. How many of you had breakfast this morning? Okay, better show of hands than last time. Those of you who didn't, when was the last meal that you ate? Last night. Like dinner time, 6, 7? So, as of right now, it's been over 16 hours since you fed your body any fuel. Okay? Do you feel like you're operating at the best level you can operate at? No. How does your brain feel? Tired. Sleepy. Fuzzy, maybe? Okay? Those of us who've had breakfast and maybe banana. Okay, go down. I forgot my bananas again. I have to go downstairs and spend a fortune on bananas. How do your brains feel? A little more awake? A little more energized? Maybe a tad bit focused? Here's the reason why. Your body's using what you gave it for the glucoses to get to the brain so that the neurons can fire and not have to worry about pulling energy from something else. When we go, periods of time before feeding our bodies, okay, the body is going to figure out a way to make glucose, because it's going to get glucose to the brain in some way. So, when we look at what happens to these molecules, note our terms here. What do you note? What do you see? What comes to mind as you read through these terms? Glyco makes you think about what? Sugars. What does lipo make you think about?
Fats.
The fats. Then we got one all the way down here at the bottom. What do you notice in that one? Our amino acids. Now, if you're feeding your body properly, giving it the glucose that it needs, we've already said we store excess glucose in the form of glycogen. Where do we store that glycogen for the most part? What two cells of the body? Liver and muscle cells. So once we store that excess glucose in the form of glycogen, when the body needs it, it pulls it out. And the process of using that glycogen is glycogenesis. Because once again, what does the term genesis mean? Beginning. Okay? So that glycogen, we pull it out, and guess what we make? Or we just kind of shift it around a little bit, and guess what we have? Glucose. Now, when we take the glucose, have too much of it, and it goes from short-term storage, glycogen, into long-term storage, which becomes the fat, okay? That glucose, with some amino acids, synthesizes the lipid that we find in the fat cells. And until we do something to actually have to use that, that's what it does. It sits in the fat cell. And if you continue to eat more of the glucoses than you use, they're going to continue to build up in those fat cells. Now, to make the lipids, once again, genesis. All right? So we're using the glucose molecule with some amino acids, and we're making the lipids. Now, when we actually go through the process of that, taking a glycogen, breaking it down, that is our term of glycogenolysis. So to take the glycogen and break it down, we have to split. We have to shift it around a little bit. Now, if we get to a point where we haven't had the right foodstuffs in the body, maybe it's a period of starvation or famine, whatever the case might be, the body is still going to try to get glucose to the brain. And it's going to take materials that have absolutely nothing to do with the sugar and break them down and use them to build a sugar. This is the term of gluconeogenesis. Neo meaning not related at all. Totally new products. Well, I guess I should say reactants to get a product. So it will use amino acids and glycerol to make a carbohydrate. To get the amino acids, it's got to break down most likely the muscle of the body. Does that make sense? The overall goal is what? What's the overall goal of all of this? The glucose molecule. So, when we look at what the body can do, the glucose, the sugar that we can put into the body by way of our foodstuffs, first thing we want to do is we want to make sure that we give the body the proper amounts. But we need to give the body the proper amounts for the energy that we're demanding. The higher the demand, the higher the intake can be. If not, the more we're going to store it. So the glycogen is our first form of storage. From that point, we're going to do long-term storage, and the body is going to go through conversions to make that glucose. And then, of course, if we need to store it in that lipid format. Now, when we take in our foodstuffs, our body goes through what we term metabolic states. Have you ever wondered about your metabolism? See a couple heads saying yeah. How? Why?
Because metabolism makes you not store all the food that you eat and breaks it down and uses it.
The higher the metabolism, right, the more you're going to use the products that you feed your body. Have you ever thought of it any other way? No? Just in that way. Don't think about it as, okay, well, or it's way too hot. No? All right. Well, our metabolic states, we're thinking about them in relationship to when we eat. How many of you kind of have what society considers the norm? Breakfast, lunch, dinner. Pretty much. How many of you have that pretty much the norm? Breakfast in the morning, lunch in the afternoon, dinner in the evening. Eat whatever you want? Wow. Okay. My problem is I could eat. Well, when we look at the metabolic states, we're basing the metabolic states on this kind of normal time frame that says breakfast, lunch, dinner. And we think about breakfast morning, lunch, afternoon, dinner, evening, and then we go all the way until breakfast the next morning. So that tells us short amount of time between breakfast and lunch, short amount of time between lunch and dinner, but an extended amount of time from dinner until breakfast the next morning. Because it's pretty much assuming you're going to do what during that long time frame? Sleep, okay? But you're going to sleep. So when we eat,